Okay, welcome back. Again, we're going to take another look here at this feature that you get with a distributed switch called traffic filtering and marking policy. What you do, as we were saying just moments ago, you apply this to port groups or to uplink groups where you might want to add a filter or a way of marking traffic for quality service types of workload characteristics. So with these policies, like I said before, you can set an allow policy that allows one type of traffic or maybe two types of traffic and then denies everything else. Or you can add a rule that says, well, we're going to deny a couple things and then allow everything else. However you want to do this. This is not a firewall though. This is adding a packet filter on the switch port. So how do you do this? Well, basically in a port group, or an uplink group, you edit the settings for traffic rules. You specify you would like to create a new traffic rule, specify for our port group, like we see here for the production port group, we're going to give the the traffic rule a good name. A name like the book is suggesting, network traffic rule 1 is too generic, I find. You're going to want to give it a rule that says what it is that you're trying to set up some kind of control for. Now you'll notice that these traffic rules have actions. You specify the direction that you're applying the rule and then a qualifier. So the action here is specifying whether or not we're going to allow this type of traffic and thereby dropping everything else, or drop a specific type of traffic and therefore allowing everything else, or are we going to add a tag, which is basically going to append to either an Ethernet header or to an IP header some quality of service specifications. You can specify the direction. Is it ingress, egress, or both? And then you add a traffic qualifier. What's the whole criteria here on which we're going to apply this rule for? And so you'll notice that there are some major categories. There is IP qualifiers, there are MAC address qualifiers, and then there's also system traffic qualifiers. And you'll choose which one of those you would like to apply the rule to. So let's take a look at an example. So in our first example, we're creating a traffic rule that we're going to allow a certain type of traffic, right? We're going to allow ingress, so it's not applying to any outbound traffic. And then we're going to set up a qualifier for a MAC address based qualifier. Notice the ether type says it's IP version 4 traffic. It's for VLAN ID 32, which is already setting up some basic guidelines here, right? We're only going to allow VLAN traffic that is on VLAN 32 as long as the source MAC address matches a range of MAC addresses that start with 005056. And then the rest of the range of addresses, those are, if you are familiar with the OUI of 005056, that's a VMware OUI, meaning that this is a VM that was built on vCenter. So basically we're saying VMs that, or I should say traffic is going to be allowed as long as it came from a vCenter based virtual machine on VLAN 32. There isn't any rules for the destination, so we're not interested in filtering where the traffic's going. It's more of we're going to only allow this ingress traffic as long as it's on VLAN 32. So I know you may be thinking, well, wait a minute, can't we just do that with virtual switch tagging when it comes to VLANs? Yeah, you can. You can apply vSwitch tagging and say we're only going to allow VLAN 32 and be done there at the virtual switch level. Where this can be applied is if you were instead doing another type of VLAN tagging. We call it VLAN or virtual guest tagging, or we call it in the virtual switch or in the distributed switch, virtual machine trunking, where in this case, we're allowing the VM to tag the traffic. Normally when we do virtual switch tagging, this is done at the virtual switch and the VMs are not aware of this. But if you do virtual machine trunking, the VM can actually provide whatever VLAN they like. Now that puts a lot of flexibility in that configuration. So if you'd like to give the guest some flexibility and then control the VLANs this way, you can. So that's basically what we're doing here. We're only going to allow traffic that belongs to VLAN 32 to the virtual machines, provided the traffic comes from another virtual machine. In another example, here we're creating a rule, again on the same port group called production. We're going to have an allow rule for both ingress and egress. So again, we're going to allow this and we're going to block everything else. And basically, this is a rule based on system traffic designations. Here in this case, we're only going to allow VM traffic through this port group, which makes sense. It is a port group, so it should only belong to virtual machines. But if for whatever reason, traffic comes from another source, maybe it's IP storage traffic, or maybe it's vMotion traffic, or maybe it's vSend traffic, if that comes through somehow on this port group, it'll be blocked by this filter. so that it will only allow VM traffic, giving you another level of filtering if you'd like to apply it to your port group here. And then finally, network traffic marking, right? The ability to add to the Ethernet header and to the IP header additional details about quality of service attributes. Again, this is supported on both layer 2 as well as layer 3. For layer 2, it's referred to as class of service. For layer 3, it's known as the differentiated service code point, or DSCP, running in layer 3. Basically, if you've provided some high-level priority in the virtual network and you would like to continue on that same priority as it goes on to the physical network, we could do that by participating in whatever the customer's network configuration is configured with, whether it's class of service or with DSCP. So in our example here, we're creating a rule that we're going to tag traffic, right? So notice the action is tag, but we're only going to choose DSCP tag 26 for ingress traffic. And basically what this is basically adding some prioritization for quality of service for voice over IP, making use of the service initiated protocol, SIP, where that as long as the traffic comes in, as you notice the traffic qualifier here says the source port is any source port, but the destination is going to UDP port 5060, which is this SIP based traffic. As long as the source IP address matches the network of 192.168.2, and the destination is to anybody else on that same network, but basically it's being addressed to UDP 5060, it'll be appended with the tag 26 in the IP header. So this is the typical tag for this type of traffic. So it applies here. If it is high priority in vSphere, it'll be applied to the same traffic as it ventures on off to the physical network. Also, in our lesson here, we'll take a look at a new feature introduced in vSphere 7. Basically, with vSphere 7, we have, of course, this new NSXT version called NSXT version 3. And there are virtual switches that are created by a distributed switch, but it's not the same kind of distributed switch because of the fact that NSXT is capable of running on other virtual platforms and other physical platforms. It goes and builds its own distributed switch called an NVDS. The thing is that if you were to build one of those NVDS objects and you create some logical switches on that object, you would like to have those presented over to your vCenter system too, so that you have a port group you can assign your virtual machines to. So there are some requirements, right? Everybody needs to be running on the latest version of their software. vCenter needs to be running vSphere 7. ESX also needs to be running on vSphere 7. Your distributed switch needs to be at distributed switch version 7.0. And you'll need to be running the latest version of NSXT Data Center, version 3.0. Your vCenter server must be registered with the NSX manager as a compute manager. And then for logical switches that you build in your NSX environment to be visible in the vSphere client, you must configure your distributed switch with the NSX port group from the transport zone. But once you've done that, then just also keep in mind, you're only really seeing the switching infrastructure from your NSX environment on your vSphere environment. So keep in mind, managing the NSX constructs is done through NSX Manager, its own user interface, right? The NSX Manager would be the area where you'd manage your distributed switch, manage the configuration of the logical switches, the NSX port groups basically, and manage the configuration of your NSX ports. From the distributed switch standpoint, you're basically able to view the NSX configuration data, some of it. You can assign your VM adapters or virtual NICs to the NSX port groups, just like you would with any other standard or distributed switch port group. And you can use vMotion to migrate a VM back and forth from these NSX port groups. And we can add VM kernel adapters to them too. So you can basically use them. We just don't really have any manageability from the vSphere client because that's really managing our vSphere-centric components. In the user interface, how it will appear with a indicator that it's an NSX construct. You'll notice over on the navigational panel over on the left, the different logical switches have a blue letter N associated with them. That's your indicator that this is a logical switch from NSX. It's not a traditional distributed switch port group. Selecting that logical switch, LS01, for instance, or LS-1, you'll find that in the main panel, it'll then be indicated with an orange N, again, indicating that this is an NSX construct. You're not going to be able to make any real configuration changes from the vSphere client to this thing. What you're able to do, though, is assign virtual machines to it, which means it's great. It's being projected by the NSX servers, and making it available for us to use for our virtual machines. So to review here, we've actually gone through several things as they relate to virtual switches, distributed virtual switches in particular, and we did cover one of these things. For instance, when the route based on physical NIC load teaming policy, right, in the vSphere client, is this something that will verify the connection is tested every 30 seconds and the load in the uplink exceeds 75%, what will happen? Will it move the VM with the highest IO to a different uplink? Is that a true or false statement? Well, this actually is a true statement. It's exactly how it behaves. Load-based teaming is this distributed switch feature that is aware of the load on the uplinks and reduces the load if needed. Very, very nice. So we have some labs here. First lab up is to basically access your lab environment and configure some basics. Notably, what you'll do is you're going to add 2 ESX servers in addition to the pre-built lab environment. Lab number 2 is building that distributed switch, which I gave a demo of a little bit earlier ago. So lab 1, you're going to basically verify a few things. The vSphere licenses should be valid, but you should verify that. And if they're not valid, then what's the step process to get them configured? Well, following the steps in the lab manual will instruct you on doing that. However, you shouldn't have to do that. The licenses should be valid for some time, but it's an optional step. And then what's important though is adding your 2 ESX servers to the lab environment. I'll show you this process here after the break. Of course, lab 2 is then creating that distributed switch, the one that I was demoing earlier, DVS lab, and add your hosts to that switch. Add your VMs to that switch. Let's take a quick break. I'll come back and I'll show you how to access your lab environment and show you what you expect to find once you're there. So see you on the other side.